Hi, folks. Hope you all can hear me. I am Dr. Chandra Dinavahi, and I really apologize for posting this a little bit late. And I tried to post some couple of things in Collaborate, but the Collaborate has some issues. So I think I waited until today until all the issues are resolved. And again, this is going to be just on section 2.1. I want to make sure you all can access these things. And I'll post one more today. And once I feel that you can access both these videos, and if you are satisfied with it, I'll post a couple more in the next week. So once you go through this, please make sure you let me know about your opinions on this. Okay, guys. So let us start. Again, I had a PowerPoint presentation which I'm sharing and editing on that at the same time. So please go through that and see how you feel about it. Okay, folks. Okay, the share. I think you all can see the PowerPoint. This is Math 540, and the course is Applied Combinatorics. And again, if you go through this course, this is like hodgepodge of different topics, again starting from basic counting rules to graph theory and sort of somewhat the design theory and somewhat probability, and these things are somewhat interlinked, but you can study them independently as well. But the chapter 2 and 3 are sort of the basic building blocks on which the entire foundation is built upon. So again, I'm posting this PowerPoint or the video on just section 2.1 because I don't want to post really long videos because it takes a really long time for you to download and all. So I try to keep these videos and the PowerPoint presentations very short. So I'm assuming some of these counting rules you had seen before, some of these you might not, but I'm assuming you haven't seen this in the recent past, and I am proceeding. So chapter 2, that is where our starting point. So the basic counting rules. So you all know what counting is. It's not very difficult. But I'm starting with the basic counting rule, which is the product rule, and which is easy to understand, and it has lots and lots of applications. And once I finish this 2.1, I will post one more today, and then I'll post an assignment on these couple of sections. And again, after every video or assignment, I'll email you all. Once you receive an email from me, then you start going through these things. Okay, guys, so let us start from section 2.1. The first counting technique which we are going to see is the product rule. And again, the product rule is not very difficult to understand, but I'll try to explain it with the help of an example. Let us go through this example. For example, you are starting from Findlay, and suppose you want to visit your friend in Toledo and you want to spend some time with him, and then from there you want to go to Detroit. Suppose there are two different routes from Findlay to Toledo, and I'll call this as highway A and I'll call this as highway B. And suppose there are three different routes from Toledo to Detroit. Maybe I'm calling these as highway 1, highway 2, and highway 3. Now I want you to find out how many different ways you can travel from Findlay to Detroit through Toledo. So you want to start from Findlay, go to Toledo, and then go to Detroit. How many different routes are possible? Again, this is somewhat, since the numbers are really small, you can manually sort of count them and go for it. For example, I can go via A, and then I can pick either A1 or A2 or A3. That means if I go by A and I can pick any of those routes. Similarly, I can pick B1, B2, and B3. So there are total 6 different routes you have from Findlay to Detroit. There are 6 different ways you can travel. This is the basic thing for the product rule. That means I can do the first job of going from Findlay to Toledo in 2 different ways. and I can pick up the second job, which is completely independent of the first one, in 3 different ways. So I can do these both jobs one after the other in 2 times 3, 6 different ways. So the total number of ways of doing this job is 6. This is the product rule. Let us go to one more example. Suppose a woman has 5 blouses and 3 skirts, assuming that they all match. Of course, as a math guys, we really don't care. But how many different outfits she can wear? That means she has to pick a blouse, that is one job, and she has to pick a skirt, that is another job. See how many ways you can do each job. So there are 5 different blouses she can pick, and there are 3 different skirts you can pick. So 5 times 3 is 15 different outfits she can wear. So I think you all got the idea of the product rule. I'm going through the definition here. If you can do one job in n1 ways, and you can do a second job independent of the first one in n2 ways, then you can do these 2 things in n1 comma n2 ways. It's as simple as that. Again, you can generalize this. That means if there are like more than 2 jobs or 3 jobs or 5 jobs, it really doesn't matter. You can say there are like 5 shirts, 3 pants, and 2 ties. Then how many different outfits you can pick? That is 5 times 3 times 2. So you just multiply these things. Please remember, each and every job should be independent of the other. Okay, that is as simple as the product rule. Now let us go to a little bit of complicated example, because we don't want to simply stay with simple examples, right? Let us go with a little bit of involved one. Let us go to this example. A bit or a binary is like 0 or 1. This is mainly used lots and lots in computers. For example, when you type an email or send something through computers, it converts everything into binary digits and sort of encodes it and then sends it. So this is a very nice variety of applications. But I'm not going to deep into that. So a bit means a 0 or 1. It's as simple as that. A bit string means a sequence of bits. For example, if you see that 0011 is a bit string of length 4, that means it has 4 digits and each and every digit is 0 or 1. Similarly, 110, it has 3 digits. Each and every digit is either 0 or 1. Now my aim is to find out Bn means if you take all the collection of bit strings of length n, that means B4 means collection of all the strings of length 4. B3 collection of all the strings of length 3. Now you want to figure out how many different bit strings are possible of length n. That is what we are trying to find out. So this is what we want. Okay, folks. So this is what we want. So now let us start with B2. B2 means bit strings of length 2. How many different bit strings of length 2 are there? For example, that means length 2, how many different strings are there? So I can have both zeros, or I can have 0, 1. This is one string of length 2. And I can have 1, 0, and I can have 1, 1. There are 2. Each and everything is length of string 2, and each and every number can be either 0 or 1. So there are total 4 different bit strings of length 2. That's what you need to find out. If it is B3, how many of these things exist? If B4, similarly Bn. Can you generalize this? That is what I'm looking for. Let us do one more. Okay, let us see B3. That means you need to find out all the bit strings of length 3 and see how many of them are there. Anything you can either, there are 3 choices. Each and every place, either you can put 0 or 1. 0 or 1. It is as simple as that. So you can either start with 0 or you can start with 1. Now you need to fill how many different ways I can fill these 2 spots. Similarly, these 2 spots. Now if you observe, once I finish the first spot, this is nothing but string of length 2, and I know there are 4 of them exist. So there are 4 different bit strings of length 3 which starts with 0 0. That means it can be 0 0, or it can be 0 1, or it can be 0 1 0, or it can be 0 1 1. So these are all bit strings of length 3 which can start with 0. Similarly, if you start with 1, these two is a bit string of length 2, so it can be 0 0, it can be 0 1, it can be 1 1 0, or 1 1 1. So these are all the bit strings of length 3 which starts with 1. Since each and every number is either 0 or 1, I think we exhausted all the possibilities. So there are 8 different choices. Now if you want to find out B4, how many do you think are there if you list all of them? You can see that you can either start with 1 or 0. If it starts with 1, there are these many possibilities. If it starts with 0, these are these many possibilities. But see, listing all of them and then counting them is just a pain in the neck. So we have the product rule at our disposal. So we want to use it to figure out how many of these things are possible. Again, my aim is not to list them. If you want to list them, there is no other way. You have to do it. But I want to find out how many of them are there. Let us see how we can use the product rule. For example, if you see B2, it is a string of length 2. Each and every spot I have to put either 0 or 1. That means I'm doing 2 jobs. I need to pick up the first number and the second number. How many different choices for me to fill this spot? Either 0 or 1. There are 2 choices. And how many different choices I can fill this spot? Again, 2 choices. So there are total 4 different possibilities. I think that is what we listed in the previous one. Similarly, if you see B3, there are 3 different spots I need to fill. This can be done in 2 different ways, either 0 or 1. This can be done in 2 different ways. This can be done in 2 different ways. So the answer is 2Q. That is going to be 8. If you have B4, you can see that how many different bit strings of length 4. Each and everything can be filled in 2 different ways. So it is 2 power 4, 16 ways. So if you generalize that, I think you all got it. What do you think is the answer? I'll give a minute. There are n spots I need to fill, and each and every place I have 2 different choices, and I'm multiplying them in n ways and times. So 2 power n is the answer. That is the power of the product rule. So if somebody asks how many bit strings of length 6, the answer is simply 2 power 6. You don't need to list all of them if you don't. That's just a pain. So again, in the exam or in the assignment, feel free to leave the answer as 2 power 6, and that is 64. So this is a little bit of a complicated example, but I think you all understood this. So I'm assuming you're all fine so far. If I'm going too fast, if I'm speaking too quickly or anything like that, please email me and let me know. Now let us do one more example. Again, this example is straight from the textbook. So if you have the textbook, this is example 2.3 on page 19. Okay, guys. So feel free example. But I feel somehow this is very interesting example. So I am going over this. Again, this is a practical example. It picked it up, I think, from the history, I guess. So at one point of time, it seems the local numbers were given by 2 letters followed by 5 numbers or 5 digits. How many telephone numbers are possible? Okay, I'll give a minute. Go ahead and try that. There are like your telephone number can be 2 letters followed by 5 digits. 1, 2, 3, 4, 5. So there are 7 spots you need to fill, and you need to figure out how many different choices to fill each spot. Now, this can be any letter. How many different choices I have? There are A to Z. So there are how many letters altogether, guys? 26. 26 different choices. Similarly, how many ways I can fill the second spot? Similarly, the same thing, 26 different choices. Now these are have to be digits. So how many different digits are there? The most common mistake I have seen people doing it is people put 9. People put 9 there. So the answer is, you know, that it is total 10 digits, 0 to 9. There are 10 digits. So just 1 minute, guys. I want to make sure my audio is recording. Yes, it is. It is recording. I'm sorry. I'll go back to this. I will go back to this. Where is this? Okay, it is still sharing. I am assuming it is. Is it sharing? Okay. Hope you can still follow this. So 0 to 9, there are 10 different numbers. You can count 0, 1, 2, 3, 4, 5, 6, 10. There are 10 different numbers. So there are 10 different ways to fill each spot. So the answer is 26 square times 10 to the 5th. Please don't worry about simplifying it because this is just an ugly number. I am more than happy to see this as the answer. In fact, I prefer this rather than simplifying. Okay, so these are that many telephone numbers. It is just by using straightforward product rule. Now let us complicate this further, shall we? Now I am asking how many different telephone numbers are there? That means I'm saying all these telephone numbers are different. What do you think? Again, from my tone, you can understand that all these telephone numbers are not different. I will explain why. If you want to understand why all the telephone numbers are not different, let us look at the telephone pad. This is the way the telephone pad looks like. Again, feel free to have the telephone pad in front of you, or this is the way the telephone pad looks like. You will have one here. You will have A, B, C, 2, D, E, F, 3. Right? I think this is the way telephone pad looks like. MNO6, PRS7, TUV8, WXY9. I'm pretty sure there is one more line. There is going to be a star here, there is going to be a 0 there, there is going to be a pound sign. I think this is the way the telephone pad looks like, right? I think I'm okay here. So let us see. When I say that there are this many telephone numbers, 26 square times 10 power 5, see how many of them are actually different. Let us come back to this. Okay, let us come back to this. For example, your telephone number is BD45321, okay, and your friend's telephone number is CE45321. Technically these two should be different, am I right? But if you want to dial, so if somebody wants to call you, what they're supposed to press on the pad? B means they have to press 2, D means they have to press 3, and then 4, 5, 3, 2, 1. Okay, That is your telephone number. Now, if they want to call your friend, C means they have to press 2, E means they have to press 3, 4, 5, 3, 2, 1. That means both of you have the exact same telephone number. So, this adds to confusion. That means that clearly shows this 26 square times 10 power 5. If you look at all those numbers, so many of the numbers are matching just because the way the telephone pad is designed. So certainly these are all not different. Now your aim is to figure out how many of these numbers are different. That means if you in your list, so here the way you need to see that is B, C, it doesn't really matter. They all count as just one letter. D, E, F, they all should be counted as just one letter because you are pressing the same thing. Similarly, T, U, V, it doesn't matter. All these considered as just one letter. So can you tell me how many different letters are there? So the different letters, if you see that, how many different letters are there? There are not 26 what initially thought of. There are only 1, 2, 3, 4, 5, 6, 7, 8. There are only 8 different letters. There were no letters either on 1 or 0. So the total number of different letters are only 8. So how many different telephone numbers are possible? You need to have 2 letters followed by 5 digits. So there are only 8 different letters. So I have only 8 choices to fill this part, and there are only 10 ways to fill 0 to 9. So there are only 8 square times 10 to the 5 different telephone numbers are there. It's not the 26 square or times 10 power 5. So these are the only different telephone numbers. I think these are approximately equals to 6 million. There are only 6 million different telephone local numbers exist. But the total number of people are using telephone is way more than 6 million. So how you are going to accommodate all those folks? That was the problem which persisted for some time in the telephone department. So what they did was, let us add some more fun to this given problem. These are local numbers. Please remember, these are all local numbers. What they did was, if you want to dial to a long distance, they included a 3-digit code to the local number. This is a long distance code. And followed by 7-digit number, 2, 3, 4, 5. Again, these are letters and these are digits. You know how many different telephone numbers are there. This you'd already done. Now if you want a long distance, you need to add a 3-digit code to that. Now the restriction for that is, this cannot be 0 or 1. That was the first rule. And the second rule is, this has to be 0 or 1. And the third digit, there is no restriction. Now I'm asking how many possible telephone numbers exist. Again, the same spot. You need to have 10 different spots to fill. And these are local numbers. This we had already done before. So now you need to figure out how many different ways I have to fill these 3 spots. There are total 10 digits, right? 0 to 9. How many different ways I can fill the first? It cannot be 0 or 1. It can be any other digit. So how many different ways I can fill this spot? 8 different ways. Right? From 10 digits, you remove 2 digits. So it can be 8 digits possible. 0 or 1, it has to be 0 or 1. So there are only 2 choices to fill this part. This has no restriction. So this one, if you multiply this huge number, that is going to be the total number of possible telephone numbers. So that is going to be 8 times 2 times 10 times 8 square times 10 power 5. If you use your calculator to multiply this, this is close to 1 billion. Again, of course, they changed a couple of them and put some more restrictions on this, and they improvised this a bit because you know you want to reach more and more customers, so you want to have different and different telephone numbers. But I don't want to discuss this because I want to add a couple more problems like this on the assignment. There we are going to explore this further. Okay guys, so as a first recording, I don't want to proceed too long and I want to stop at this point and just summarize a bit what we had seen so far. Again, the important point in this section is the product rule. Product rule simply says is if you are doing multiple jobs and if those jobs are independent of each other, if you know how many different ways you can do each job, then all these jobs can be together done in multiply the individual things, and that should be your answer. So that is the most important thing. So you need to, if you know what are the numbers you're multiplying, that is how many ways you can do each piece. And the most important thing is each and every job should be independent of the previous thing. So the previous result shouldn't affect this. Then the product rule works. Okay guys, I stop at this point, and if you have any questions and if your recording is not so great, if the way I speak or if I'm speaking too fast or any concerns, please let me know. If you prefer to meet online rather than seeing these videos, that sort of helps you a bit, we can do that as well. Maybe next week we can do that. Just let me know. Okay, I'm going to stop share this now. So hopefully you all have that. Okay, now let us see this. Now I am going to stop the recording